Hey everyone, and welcome. Today, we're going to dive into some really cool specialized tools in the C++ toolkit, container adapters. Now, I know they might sound kind of complex, but trust me, they're all about making our lives as programmers a whole lot easier by using a few simple but super powerful rules. So, to get us started, let me ask you something. I want you to picture three totally different scenes. First, a stack of clean plates at a restaurant. Next, a line of people waiting at the checkout. And finally, the triage system in a packed hospital ER. So, what in the world do these three things have in common? Well, the answer is all about structure. Each one of these follows a specific, kind of unwritten rule about the order of operations, who or what gets taken care of next. And these real-world rules are the perfect picture for the C++ tools we're about to unpack. All right, let's put a name to what we're talking about here. We're getting into container adapters. And honestly, the name kind of gives it away. They adapt the containers we already know to give them a much more specialized, focused job. You're not reinventing the wheel. You're just putting the right kind of tires on for the race you're in. So what is a container adapter, really? Here's the key thing you've got to remember. It isn't some brand new container built from the ground up. Nope. Think of it more like a wrapper. It takes a standard container you already use, like a deque or a vector, and basically puts a new, stricter lid on it. It's all about enforcing rules for how you get to the data inside. So in the C++ world, we're going to focus on the big three: the stack, the queue, and the priority queue. And what's cool is that each one of these lines up perfectly with those real-world examples we just talked about. Let's break them down. All right, first up, the stack. And for this one, I really want you to lock that image of a pile of plates in your head. You add a new, clean plate to the top of the pile, and when you need one, well, you take it right from the top. And this is where we get to the core rule of a stack: LIFO. That stands for last in, first out. It's just like the plates. The very last plate you added to the pile is always the first one you grab. And this simple rule is incredibly powerful for solving certain kinds of problems. And the way you work with it, super intuitive. You want to add something, you push it onto the top. Need to take the top item off, you pop it. And if you just want to peek and see what's on top without actually removing it, you use top. It's that easy. Okay, so that's the stack. Now let's shift gears and talk about our next one, the queue. So ditch the plates for a second and instead picture yourself waiting in line at the grocery store. It's all about fairness, right? First come, first served. And this, of course, is the perfect example of FIFO. First in, first out. The first person who gets in that line is the first person who gets to check out. In our code, this just means the very first thing you add to a queue is going to be the very first thing you process. It keeps everything in order. The operations for a queue totally reflect this real-world line. You push a new element to the back of the line, but when it's time to process something, you pop it from the front, and that's the absolute key difference from a stack, right? You add to one end, and you take from the other, just like a real line of people. Okay, let's just pause for a sec and put these two head-to-head. You've got the stack, which is LIFO, last in, first out, like grabbing the top book off a pile. And then you have the queue, which is FIFO, first in, first out, just like waiting your turn for tickets. Two simple, opposite rules that are the key to so many problems. All right, time for our third and final adapter. And this one's a bit of a rule breaker. Forget first come, first served. We're back in that emergency room. Someone who walked in an hour ago with a small cut is still going to wait longer than the person who just got rushed in with a serious emergency. What matters here is priority, urgency. And that, right there, is the entire idea behind a priority queue. It could not care less when something showed up. All it cares about is priority. The element with the highest priority, the biggest emergency, always gets moved to the front of the line. It's like a self-organizing line that's constantly pushing the most important thing right to the front. Now, the function names might look a little familiar, kind of like a stacks, but how they work is completely different. When you push a new item, the priority queue automatically finds the right spot for it based on its importance. And when you pop, you don't remove the oldest item, you remove the highest priority one. Same with top. It always lets you see that top priority item. Okay, so that's the theory. But what good is theory if we don't see it in action, right? Let's get our hands dirty and see how these things actually solve real problems. So let's take a look at a classic programming challenge from Kattis called Slide Puzzle. You know those little 3x3 puzzles where you slide the tiles around to get them in order? The question is, how do you write a program to solve it? You need a systematic way to explore all the possible moves you can make without just getting lost or going in circles forever. Well, this is a job that is perfect for a queue using a classic algorithm called breadth first search, or BFS. Here's the game plan. You put your starting puzzle into the queue. Then you take it out, you figure out every single possible next move, and you add all of those new puzzle states to the back of the queue. See, because the queue is FIFO, it guarantees that you explore all the puzzles that are one move away first, then all the puzzles two moves away, and so on. It's a methodical, level-by-level search that just wouldn't work with a stack. So, as you can see, the real magic is knowing which tool to pull out of the toolbox for the job at hand. So let's wrap this up with a quick guide to make it super clear when you should use each one. Okay, here it is. Think of this as your personal cheat sheet. If you need to reverse something's order or deal with nested things, like matching parentheses in the select group problem, you want a stack. If you have to process things in the exact order they showed up, like in our slide puzzle or any other breadth first search, a queue is your go-to. And finally, if you always need to deal with the most important thing first, like in simulations such as Jane Eyre or Kings of the Forest, then the priority queue is definitely your best friend. And really, it all boils down to this one simple idea. Choosing the right tool, the right adapter, isn't just some minor technical detail. It's about turning what looks like a total mess of a problem into something, well, simple, almost elegant. So I'm going to leave you with a little challenge. Every single time you hit the back button in your browser, you're using a stack to keep track of the pages you visited. Your computer's print jobs are almost always handled by a queue. So think about it. What other systems that you use every single day are secretly being run by these simple, powerful rules? It's a cool way to see the code behind the curtain of everyday life. Thanks for joining me.